Okay, hello and welcome to this webinar with me, Adam Rose. In this webinar, we're going to have a look at weldments for structural steel. The first thing I'm going to do is switch over into SolidWorks so we can have a look. I've got this model open up and it's a 3D sketch. It's been drawn out around a few directions to make up the basis of what's going to be a ramp that we're going to construct out of structural steel. I've then got another sketch that we're going to use later on to generate a pattern. So to start off with, within Weldments, we need to make sure that the toolbar's turned on. So I've got it turned on at the moment, but if you do want to turn any of the other toolbars on, we can just go to the top and activate them by hitting the tick box. To activate the Weldments environment within SolidWorks, we just hit this button right here. What that'll do is it'll make sure that any new features we insert are created and are automatically created as new bodies. So I'm going to start off by inserting a structural member. Now you'll have a series of standards that have already been produced within SolidWorks that will come with the package. However, they aren't very extensive. If we do want to download other items within here, we can go into the right hand side. I'll just move down this item here. I'm just going to go into the design library and I'll open that up and you'll see that we've got SolidWorks content within here. Within SolidWorks content there's a weldment section and there's all the different standards you can download, and all you do to download these is just hold down the control key and click on the one you want to download. Now I've already downloaded one of those for convenience earlier on, so I'm just going to switch to a window where that is at the moment. So I've created a folder on my E drive called Weldment Profiles, and I've put in that extracted folder that you download. So that's the ISO standard at the moment. All I'm going to do is just, like I say, extract that to that location. So when we're creating a Weldment Profiles database within SolidWorks, we need to bear a few things in mind. I'm just going to switch back to that PowerPoint presentation so we can have a look at those things. So there's a particular file structure you need to make sure you have set up. From my Weldment Profiles folder at the top level within that E drive, I need to make sure that's a reference folder. And then you can see that the item below that, ISO webinar, becomes the standard when we start up the structural member feature. And then we have the particular type of structural member, and that goes into the type box. So that idea of having two folders until you actually get to the profiles themselves needs to be set up within your file structure within Windows. And then it will be mirrored when you open up the structural member feature. So switching back to this window, what I'm going to do is I'm going to make sure that I've got a similar system, and you'll see at the moment I've got 3 folders until I actually get to the members themselves. So in order to sort this out, I'm just going to move this folder right here. I'm going to cut it and put it at the top level. The top level is the Weldment Profiles folder. So I'll just delete this ISO folder now because I've removed all the contents out of it. And now if I reference this folder within SolidWorks, it should pick up the fact that there's structural members in this location. So that's what I'm going to do now. So switching to SolidWorks, you'll find if you go to your options menu, we'll start that up from the top. Now under file locations, we can reference all the different locations of items within SolidWorks. There's a drop down list at the top, and I'm going to scroll down that list to find Weldment Profiles. Okay, so there's the current location of those Weldment Profiles that had come by default within SolidWorks, but I'm going to add another location, and my E drive is where I want to reference. So I'm referencing that Weldment Profiles folder. Okay, it'll just ask me if I'm sure. Now that I've done that, I can now access that folder when I start up the structural member feature. You'll see that the standard is available now, ISO webinar, and I can choose from the types of item that I want to insert, as well as a whole list of different sizes. So for this first section I'm going to insert for a structural member, I'm going to choose the L angle unequal profile. and then I can choose a particular size. So I'm going to go for 150 by 75 by 9. Okay, there it is. I'll zoom in on my design and I can start selecting the lines in my sketch. So all we need to do is select the lines that we've already created. Now these can be arcs or lines, any analytical geometry within your sketch. So I'm going to select the line just here, and there's particular rules about what we can select having selected the first item. So we can either select items parallel to that, like this one here, or we can go items connected end to end, like this one. However, once we've done that, we then can't select the one parallel as well, or we can't select 3 items connected end to end. So I can't say select this leg at the same time. So we need to stick to those rules when we're actually selecting the different items when we're creating the Weldment profiles. What I'm going to do for this first group that I've selected, you'll see that the items are grouped into groups by the different selections you make. I'm going to select all the items down one side. Okay, so having selected those, to insert anything else within this structural member, I need to insert a new group. To do that, I just select the new group icon just here. And that lets me select an entirely new item here, but it has to be the same profile. It could just be in a different location. Okay, so there we have the profile selected in group 1 and 2, and we can deal with those separately within SolidWorks. So we'll have a look at group 1 first of all. That was this one over here. There's particular settings for the corner treatment, which we'll have a look at in a minute. The alignment is something I want to get right in this one. You'll see at the moment it's aligned vertically downwards with the longest leg pointed to the floor. If I do want to rotate it, it's quite simple. I just select in this box here and rotate it around. The other thing we can adjust in here is the location of the profile itself. If I click Locate Profile, it zooms in on that profile that we selected, and then we can choose any of the points in that sketch to use those as the center of this projection. So I'm going to choose this point here, and you'll see that it shifts it around. I'm then going to rotate this profile by 270 degrees, and that will rotate it facing inwards. However, that's only done one group, so you'll see this group over here is still the same as it was originally. So to do the same process in group 2, I need to go over to this bottom left-hand corner, and again locate profile, which will let me select any of those points, and we can actually insert more points than we need within the sketch to give us more options, and we'll have a look at that later on. So I'm going to put in an angle again here to bring that round to the right position. Okay, so now that I've got these items positioned nicely, there's certain settings relating to this corner treatment which we're going to have a look at. I'm going to zoom in on this corner over here, and you'll see that the corner treatment is available within both of these groups. We can change it from a mited edge to the profiles butting up to each other at the corners. Okay, and when you select this option, you get options of how those items are cropped against each other. So whether it's just a tight crop where the profile matches quite nicely, okay, or we can just have quite a simplified version. These are global settings for the Weldment profile, so this group is affected all over when we change the setting on that left. However, we can do that setting locally. For example, if I zoom in on this corner over here, I can affect just this corner on its own by selecting that purple dot. It allows me to adjust exactly the same settings. I can change how the items are butting up to each other. I can insert weld gaps. Again, we have that setting over here. Okay, so you've got a lot of options to be able to adjust things on a smaller detail as well. I'm going to untick that option to merge these miter trimmed bodies on both of the groups. Now that I've done that, I'm actually ready to accept this first structural member Okay, and exit out of the feature. So now that I've inserted that first one, I do actually want to insert a different shaped profile now. And we have to do that in a separate structural member feature. So we can select as many groups as we want of the same profile within that same feature. As soon as we want a different shape, we have to select structural member a second time and insert a second feature. So any of the sketch lines that I created earlier on, I can still use those. I'm going to select T section now, and the particular size 60 by 60. And for this one, I want to select these two lines here. Now these are both connected end to end, so this is fine. We can select both of these quite easily. However, if I want the items over here as well, I need to select a new group for those. So I'm going to insert a new group to do that. And again, I'm going to untick that option to merge those together. I've got to sort out the location of these as well, because at the moment they're upside down to the way I want them. So again, if I locate the profile first of all, I can locate them to a different point. For example, just here. And I can do that on both of the groups. Instead of rotating it around this time, you can actually mirror the profile by ticking this tick box, and that will flip it over the right way up. And we can do that on group 1 as well, if we zoom over to that corner. So you'll see that that gets it the right way around now. And you can mirror those profiles horizontally or vertically. You've got a lot of options there. So using a combination of mirroring and rotation, we can get the profile to any position. Okay, so now I've inserted that second structural member, I'll hit the tick. Now whenever we create structural members in the same feature, they're trimmed against each other. However, when we insert one structural member after another and they're intersecting, like at this corner here, the bodies will be going straight through each other. They won't be trimmed automatically. So what we need to do is use the trim extend feature to get rid of that intersecting area. So by selecting at the top, we can then choose the bodies to be trimmed and then the items to trim those with. So first of all, the bodies to be trimmed, that's these two just here, those two bodies. And then we can either trim them using faces in the model, or faces, for example, like a plane. Or we can select just the bodies, the solids themselves to trim with. I want to turn off the allow extension option because I'm not trying to extend these profiles at all. I'm just trying to trim them back. And I'm going to select that cropped cut between the profiles there. Now I can insert as many items as I want to trim within this feature. So I'll select these features, these bodies over here as well. But I've also got to select the items to trim those with. So now that I've done that, I can hit the tick and that will trim those items away. And it leaves me with a nice intersection between these two items. So I've inserted two structural members so far, but I've just used standard ones that are within the standard SolidWorks database that we downloaded. If we do want to insert anything more detailed or anything that we want to create ourselves, we can do that by actually just creating a new part document. So by going up to the top, I'm going to create a new part, and I'm going to create my own structural member. So to create this structural member, all we need is a simple sketch. To insert it, we just draw up a sketch on the front plane, for example. And to draw this out, I'm just going to do a center rectangle with a few simple dimensions. Having drawn that out, if you remember what I said earlier on, the more points we have within the sketch, the more locations we can locate it around. So by inserting more points manually, we actually get more options when it comes to locating the profile. So I'm going to insert a point at each of the midpoints along the lines within this sketch. and I'll exit the sketch. So that will become the profile that will be projected along any of the lines that we select whenever we create a Weldment profile. What I'm going to do now is to insert a property within this document. So I'm going to go to File and Properties. If we insert a description with our Weldment profiles, it will be brought through whenever we create a cut list. So it simplifies the process for us. So I'm going to put in some information about this profile. And accept that change. So by inserting it as a description at that level, it saves us work later on inserting it for each individual body when we actually get to create the structural member, the cut list, sorry. So now that I've done that, I'm going to save this profile away. What you've got to do is just select the sketch on the left hand side so it's chosen in the tree, and then go to the top and select Save As. What we want to do is to save this in the same location as we created our Weldment profiles earlier on. However, this doesn't want to be a part document. It wants to be a library feature part, SLD LFP. When we select library feature part, it takes us to the design library. That's the default location for these items. So I'm going to browse back to my E drive and then go into Weldment profiles, into that standard I created earlier on, and I'm going to create my own folder in here to define the type. So having done that, I can then save my document in this location. It's got to have a fairly sensible name, because if you remember, that's the item that will come through and show up when we create this profile. So I'll click Save to save that away. And now I can close this down. So within SolidWorks now, when we select structural member, we should find that that new standard that we just created, that folder that I've just made, appears in the type list, and so will the profile. I can then insert that on any of the other lines that I've got within this design. So I'm going to insert first one here, and it's inserted at the point where the origin was in that sketch. I'm now going to insert a new group, and my new group is going to be selected over here, and a third group is going to be selected down this bottom edge. Just move it on screen a little bit. So again, now it's a process of locating these so they fit around the rest of the profiles nicely. I'm going to use the Locate Profile button to do that. This first one wants to be located by this bottom right hand corner. The second profile I'm going to locate at the bottom in the middle. But what you'll notice is when I do that, it's still not located nicely. It's not matching up to the angle of the profile below it, because I've got that 4 degrees angle going down the ramp there. So what I'm going to do to get this in position is use the alignment box that we haven't looked at yet. We can select an item in the alignment box, like this edge just here, and my profile will match up to that. You'll notice it's been flipped upside down though, so I can simply mirror that profile to get it the right way around. Group 3, I'm going to do a similar process. I've got to locate it by the opposite corner this time, because if you notice there's also an angle on this item, so when it flips over it will be the right way round. So at the moment it's the opposite. When I select the alignment box and select an edge, it flips over. So we get all 3 of those into position quite nicely and quite quickly. Instead of creating all of those profiles all within the sketch, what I'm going to do is actually create them as one structural member feature, and then just use a linear pattern to pattern them all over the design. So that's quite simple and straightforward to set up. All we do is select linear pattern from the top, and then define the direction. So there's the direction inserted. The bodies to pattern, well, the first one is going to be this one here. Usually whenever we create a pattern or a mirror from a structural member, we want to make sure we're selecting bodies rather than features. because each of the solids that we have in this document is a separate body. Whenever we create a structural member, all the items are split up into separate bodies, so it's more robust to do it that way. We'll put in the direction there, and the number of instances is correct for this first one. Insert a second linear pattern now, and this time it's going to be going from this bottom right hand edge. You'll notice the arrows pointing in the wrong direction, so I'll flip that around. And again, I'm using bodies to pattern. For the final pattern, I'm just going to pattern all the way down this section just here. So again, I want to use this edge. I'm going to insert more instances. I'm going to put it up to 5 for this area just here, but I'm keeping the distances exactly the same. Okay, and now I've inserted those. I've got the slats all over this design. And all I need now is to insert some legs to actually hold this thing up. To insert a leg, it's another structural member feature. So from the Weldments toolbar, I'm going to insert that one very quickly. This one is going to be a square tube. Okay, and here's the size I'm looking for. Within the groups box, I can actually put these all within the same group, because if you remember what I said earlier on, if the items are parallel to each other, they can be selected within the same group. So because all of these lines are parallel and going in the same direction, they can all be selected together. The location of these is okay because it actually fits within the profile that we inserted earlier on, that L angle profile. So I can actually accept these straight away. The only thing I need to sort out with these profiles is the fact that once again they're intersecting through this structural member just here. So in order to sort that out, I'm going to use the trim extend feature once more. So in the top box, I select all the items I want to trim away. And then I'm simply selecting the trimming boundary, which is those edges around the design, so those bodies that I've created earlier on. We're going to go either side as well for all of these. What you'll notice is that in the center we've got bodies to keep and then bodies to get rid of. So once again, I'm turning off allow extension because I don't want any of these to extend at all. And I'm just going to crop them with a crop cut because I do want them to crop at that angled edge. And then you can see that setting, bodies to areas to discard and areas to keep. And we can change those over if they're not quite right. So we can flip it over to keep areas in the design just simply by clicking in the text just there. So it's quite easy to adjust the item to exactly what we want. So by hitting the tick now, we accept the settings straight away. It does quite a good guess initially of actually guessing which items should be kept and which items should be disposed of. And that nicely just creates a simple angled edge on the edge of my profile so they don't overlap anymore. The next part of the design I'm going to insert is going to be a foot that sits on the underside of this leg just here. To insert it, I'm just going to zoom in on the bottom of this leg over here and do a sketch on this face just here. Again, I'm using a center rectangle for this. Okay, now I've inserted that sketch, I'll just exit out and I can create an extruded boss from this. So when I select extruded boss, It's exactly the same as the feature you'll find on the features toolbar. The only difference being when I've turned on that Weldments feature, first of all, it unticks the merge results option so that, again, like say, this body will be created separately. Any new items created are no longer joined to the rest of the design. So even the feet will be separate items within this model. So I'll create one of the feet over there. And for the rest of the design, I'm going to pattern them all over the model. So I had this sketch created at the start. That was the points at the end of each of the legs. I can now use that to drive the generation of the instances within that pattern. So from the features toolbar, if we drop down, there's a sketch-driven pattern as an option. Sketch 2 is selected because I chose it before I selected sketch-driven pattern. So all I need to choose that body, the bottom of that leg, the foot that I've just created. And I'm doing it by the centroid, which is at the center of mass for this particular body. So I'll hit the tick, and that will create the feature. So it's a really quick and easy way of getting the feet all over the model, but they are in quite different areas of the design. So you couldn't use, say, a linear pattern that easily. What I want to do now within the model is insert handrail. To draw that out, I'm going to show you how to draw a 3D sketch for the construction of a weldment. From your Weldments toolbar, you'll find 3D sketch. Obviously, it's a bit more detailed, a bit more complex than drawing a 2D sketch out because we're sketching in 3 dimensions at once. To start off with, I'm going to select my corner rectangle tool. I want you to notice this triad in the bottom left-hand corner, because as I'm drawing this sketch out, the sketch will reference that triad. For example, at the moment I'm sketching in the XY plane. If I press the Tab key on the keyboard, I can flip to one of the other planes in that triad. That's the YZ plane. Okay, and then you can flip to that third plane as well. So you can have a variety of different options to get those geometry created initially in about the right place. So I'm going to create just a rectangle at this location. However, what you'll find when drawing in a 3D sketch is that if I rotate around now, the item that we thought it was in, so the location of this sketch isn't quite right as to where we're looking at it from. So in order to get this sketch right, what I'm going to do is just delete it out. Okay? And I find it a lot easier to draw 3D sketches from a particular perspective and then rotate myself around later on. So if I bring myself around to the right plane, I'm going to draw my sketch from this direction. In order to simplify the design slightly and get rid of some of the detail I don't need, I'm going to hide the items in the cut list by right-clicking on it and clicking Hide. The cut list is all of those solid bodies within the design, and we'll have a look at actually using that later on. So again, I'm drawing out a rectangle this time. By drawing it from the right plane, it helps us to lock down that depth a bit better. We get it in about the right location before we start. And then if you see, we'll rotate around. Okay, it means that then you can use sketch references to get it to exactly the right place. So I'm just going to delete this line just here. I'm going to insert some sketch lines. Now, when we're inserting simple lines within a 3D sketch, instead of having horizontal and vertical, we have along Y, as you'll see I've got next to my sketch line now. And then we've got along Z, we go sort of vertically across. Okay, and if I was going to go into the depth direction, we'd get along X as well. I'm not actually looking in the right location at the moment. So we use those references instead of horizontal and vertical to get our sketch lines in the correct location. Some of the other references are still there, like coincident. You can still use that. However, I'm going to use along Y on this one and along Z on this line here. to get this locked in place. And I'm just going to add some simple sketch dimensions in here to get it about right. From that location, I'm going to draw in a second sketch line. I'm going to make this line equal in length to the first one I inserted. I'm going to draw a line down that's going to be roughly parallel to the direction of the ramp. So I've made that coincident now. In order to lock in this line just here, we can't make it along X or along Z, sorry. What we can do instead is try and lock it down as to the direction of a plane. So I often use sketch planes. If I rotate myself around, you'll be able to see a bit better. I'm going to select the right plane, for example, with the sketch line that I've got there, and I'm going to make it parallel to my sketch line. And that helps to hold it in place. The last thing I'm going to do is to make the top line and this one parallel as well. And that helps to fully define the sketch. Now the great thing about 3D sketches, we can then go to a different direction, like the front plane, and draw out an entirely different shape. So we could go and draw another rectangle up here that would be another part of the handrail. However, it took quite a lot of time to draw out that first sketch. So what I'm going to do instead is actually just open up an existing model that contains a sketch that has all the handrails drawn out inside of it. But that should give you an idea of how to start 3D sketches and how to use those for weldments. So I'm going to close down this document now. Okay. If I open up this document, you see I've brought it back. It's got that cut list shown again. And we've got the 3D sketches of the handrails created all over the design. So what I want to do now is to insert the structural members around the edge of these handrails. Now we've got a slightly different situation than what we've had before with this first structural member. When we create this profile, we're going to have the items in different groups crossing through each other and overlapping. Like I said earlier on, if we create items in the same structural member, they're automatically trimmed against each other. However, it's useful to know in what order items are trimmed against each other and how to adjust that. So I'm going to switch back to my PowerPoint presentation just to have a look at how groups are trimmed against each other. So as you can see from this picture, there's an ascending order of the groups, and the group at the top, group 1, won't get trimmed against anything. And then automatically items in group 2 will be trimmed against group 1, and then items in group 3 will be trimmed against all of those that exist above. So as we go down lower and lower into the groups, the trimming order gets lower and lower as well. So for example, if I draw out this profile, I draw out around this top edge first of all. Because these items are in group 1, when I go to select the leg just here, I'll need to insert a new group. You'll see that it's trimmed just here against that item in group 1. Okay, so usually we'd have to select the legs in group 1, but if we're doing on a kind of case-by-case basis, we can adjust the individual joints if we want to. Like say on a specific corner, we can adjust the items in group 1 and we can change their trimming order. So for example, the items in group 1 that beam around the outside, we can put those into the second trimming order, so they're trimmed second of all, and then the items in group 2, we can put those into the first, which actually flips around that joint, as you'll see there. However, it takes a long time to do that for the whole design, so the easiest way to do it is to get rid of those groups and actually select the legs all in the same group, and then do the rails around the outside afterwards. So in my new group, I'm going to select each of the rails. I'm going to select a slightly different shape of profile for this one. I'm going to go for a circular tube. There we go. And I'm going to need yet another group to select these rails over here. Okay, there we go. And I'll hit the tick to accept. So that's created the handrails for this particular part of the design. Now what we're going to do is have a look at the cut list, because we've generated most of the geometry that we need for this model at the moment. We've done it all within one part, but then if we wanted to go any further, we'd probably put it into an assembly and build in the other parts of the design that aren't part of this weldment structure. So if we look at the cut list, we can adjust it and generate the items within this cut list. At the moment it's quite sort of mixed up. You've got all the different bodies in here, but they aren't grouped together in any way. So if we right click at the top and click update, it figures out which items would be grouped together and it puts them into the same group. The items which would be grouped together, for example like the feet, are the items that are all the same size. So you've got a lot of items that aren't in the same group. For example, all these L angle edges around the outside, none of them are really the same size. Okay, so you end up with quite a mixed up cut list in there. While it's ordered quite nicely, it's quite hard to take in the information when it's that long. So there are some ways we can make it simpler to take in. We can select items in this cut list, for example, like those feet, or any of the items in here, and press F2 on the keyboard, and that allows us to rename them. The other way we can deal with items in this cut list is by grouping them together. For example, this handrail over this bottom right hand side here, we could group these together by their bodies. So if I was to select from my toolbar down here, I've just turned on the selection filter. You press F5 on your keyboard to do that, just turns it on and off. We can filter by solid bodies, which allows us to select all of the solids over here. By selecting all of the solids in that group, we can then right click and create a sub-weldment out of them, which actually just groups them together. And you'll see now that those items are now grouped, but the cut list still exists within them, so the bodies are still there. So it's a great way of actually sort of controlling the items in here. Instead of doing this whole cut list and doing it all and grouping them together within sub-weldments, what I'm going to do is open up a document that I did earlier on, where I've just gone through that process of renaming and actually grouping the items together in sub-weldments. Okay, it's exactly the same in terms of its geometry. The only difference being is that the cut list now is nicely organized. So we've got items like that handrail that we created earlier on, and the other items are renamed nicely. We've still got some items at the top level in the cut list. Okay, but the rest of the items have been grouped together. If we do want to make changes to this cut list, we can adjust, say, the material for each of the bodies. So for all of these slats that I put in earlier on, I can select all of those. So I could select half of them, for example, and I could add a material to those. And you'll see that it nicely splits the group so that half the items that have that material in one group, and then down the bottom we've got the items that don't have that material. So it will do some automatic grouping still. If we give the items the same material, they're put back in the same group. And that's all dealt with by that automatic option that we got turned on there. It groups things together and splits the cut list about. The other thing we can do within here is actually edit the properties for a cut list. So if I select this item just here in the cut list and select properties, it brings up the cut list editor. And you can see that there's automatic properties created for most of those items in the cut list. We've also got the items that are created as sub-weldments. This one here. You'll see that there aren't any properties for this one. But if we go down at a lower level, we can find the cut list properties there. So for the middle handrail, I'm going to create my own property for this so that it will come in nicely in a table. I'm going to add a description to this. And I'm just going to add a description so that in a table we know that it's a sub-weldment. When we create a sub-weldment, we usually deal with the cut list in a different file, and I'll show you how to do that in a minute. You'll see that all the other items have got descriptions added to them automatically. I've added those in earlier on. So I've added all those items that are a sub-weldment with a description to tell us so. The other items in here, well, they're automatically been done by the system. You'll see that that property we entered in earlier on has automatically been added in to this item here. For the feet, they're the only item in here that actually are created just from a normal boss extrude rather than a structural member. So they don't have many properties created by default. We can create our own properties quite easily in here to assign to these though. If I put a description in here, I could then zoom in on this corner leg just here. And I'm going to bring up the dimensions for it by double clicking on the feature in the tree. Okay, you'll see that 15 dimension has gone over here. If I select it, it gets added into my description. And I'm going to put in millimeters and plate in here. And you'll see that the value is evaluated to exactly what this is. So if the plate changes in thickness at all, then so will the description. So that works quite nicely within our cut list. So now that I've entered properties for most of these, if we have a look at the cut list table in here, we can see what the cut list will look like at the moment when we enter it into a drawing document. So you can see all of those items that have been named as a sub-weldment say so. And then everything else has a nice description next to it. So now that we've sorted out that cut list, we can actually insert it into a drawing. To do that, we just go via the normal route, make drawing from part, and we can just select the particular page size. So I'll just quickly insert some drawing views from my view palette. Oops. What I'm going to do now is to just scale the drawing up a bit by going to the Properties menu. I'll just right click to get to that. And I'll just change the drawing scale. Okay, so I've inserted two drawing views. And that cut list that we were looking at earlier on, we can insert that into our document by going to the Insert menu and then selecting Cut List from the Tables section. So it's called a Weldment cut list. I'll select this document here and that's going to be what the item is related to, that drawing view. You'll see that we've got a table template, and that defines what the headers are in the table. I'm going to accept the changes, and that will insert my cut list wherever I want it. So I'll just put it there, and you can see it's brought through those properties. However, I've spent a bit of time putting in nice names so we can tell what everything is. If you do want to insert an extra column into the table at all, we can just right click on the tops of one of these columns just here and insert a column to the left. I'm going to put cut list item name as the property, and you'll see that then we can bring through those names that I've created. So I'll just scale this table down a little bit. So all of those items that are cut lists are sub-weldments within this cut list. They don't have a length within the table. Obviously that the lengths of those items are defined at a lower level. I'll just switch back to this document quickly so you can see how I can actually get to the cut list for that document. So you'll see this lower handrail just here that we created earlier on. If I right click on that and create a sub-weldment like I did earlier on, I can insert it into a new part. By inserting it into a new part, I'm saving it away as a separate document. So I can save it as lower handrail. So it's quite nice. We can almost deal with that document as a top level assembly. And then this can be the individual piece parts that we can split up later on. So you see that we've got the cut list here. We can have a look at it by going to the properties menu once more. And you can see that each of the properties for the individual items within this cut list have been brought through. Okay. If you do want to update this cut list at all, so we're making sure we're bringing through the right properties, we can right click and update it just to make sure. And then you can insert a drawing from that and pull through those properties that you created earlier on, using that same process that we just did. So hopefully that's given you a good idea of how to deal with weldments within SolidWorks, and how to get the most out of them. I'll just switch back to my PowerPoint for a minute. I want to say thank you very much for watching. I'll point out a future webinars we've got coming up. We've got one on Introduction to SolidWorks Enterprise. We've got one on SolidWorks Electrical Routing, and how to use the master model technique within SolidWorks. So thank you very much for watching.